Here we are in section 6-4, exercises 1 through 6. We're going to be solving these equations, and these equations involve rational expressions. We have denominators, which is what we've been practicing with. We're going to first, just like we did back in an earlier chapter, multiply through by the least common denominator. Once we identify that and multiply it through, boom, no more fractions, same principle. Then we'll solve like normal. And then we need to double check that our answers are okay in the domain. Now remember, anytime you have a fraction, that means you can only input numbers that will not make the bottom 0. So we have to double check that at the end of each problem. So number 1, the least common denominator, x, x, 1, so an x. So we're going to times everything by x. And we get cancel. So 3 equals 2x plus cancel 5. Oh, wasn't that nice? Subtract 5 from both sides and we get 2x equals a negative 2, x equals negative 1. This is great. Now double check. If you stick it back in here, does it make that denominator or that denominator 0? It does not. So we have an answer. That was good. And notice that least common denominator, once you multiply through by it, you have an equation that does not have fractions in it. So we might get something from chapter 2 or something from chapter 5. All right, that one was good. Number 2, this has a denominator of an x and an x plus 7. So let's multiply both of them by x and x plus 7. Notice we are not just changing the fraction by timesing the top and bottom by the same thing. We are actually multiplying both sides by a number that isn't 1. We're actually multiplying both sides by that least common denominator. And then magic happens. The x's cancel there, and the x plus 7's cancel there. We're left with 2x plus 7 equals 4x. And this is an equation. We know how to do this. Distribute, we get 2x plus 14 equals 4x. Subtract 2x from both sides, and we get that x divided by 2, x is going to equal 7. Good. Next one. Least common denominator is a 7 and an x plus a 3. Oh, this one had a number in it, 7 and x plus a 3. So we're timesing both sides by this. 7 cancels down here, and we get 2 times x plus 3. And here, the x plus 3 cancels, and we're left with 7 times x. Notice on these last two where we just have a fraction times a fraction, and the least common denominator is those two denominators multiplied together, that it ends up being cross multiplication. Not necessary to notice that, but for those of you who have heard that before and used that, that will help. All right, jump the 2 in here, and we get 7x equals 2x plus 6. And then we subtract 2x from both sides and divide, we get x equals 6/5. Oh, we didn't double check. First of all, we stick this 7 back in to make sure it's an answer. Stick it back up in here. It'll make it 2 over 7. 4 over 7 plus 7, that's 14. We will not cause 0 to go into any fraction. Here, 6/5. Nope. Nope. So it is a safe answer. Good. The next one. Let's try number 4. Ooh, this one has more of a common denominator. Notice we can't just do the cross multiplication on this. It's not just a fraction times equals a fraction. So the least common denominator needs a y and a y minus 3 in it. So let's go with y minus 3 here, times by y and y minus 3 here, and y minus 3 here. Notice we're timesing this common denominator by each term all the way on both sides of the equation. So here, this cancels, and we're left with 1 times y minus 3. The y minus 3 cancels here, so we're left with plus 1 times y equals, and then the y minus 3 cancels over here, equals a 5y. And so this is 2y minus 3 equals 5y. Subtract 2y from both sides, we get minus 3 equals 3y. Y equals negative 1. And double check that answer. Will it cause any of these original denominators to go to 0? Nope, it won't. So that's a good answer. All right, the next one, number 5. 1 over x plus 2 plus 1 over x minus 3 equals 5 over x plus 2. Common denominator needs an x plus 2 and an x minus 3 in it. So let's times both sides by x plus 2, x minus 3, times this guy by x plus 2, x minus 3, and times this side by x plus 2, x minus 3. There. So the x plus 2 times x minus 3 is one big blob. Hit this term and that term and that term. So now what cancels? The x plus 2 cancels, and we're left with 1 times x minus 3. What cancels here? The x minus 3 canceled, and we're left with plus x plus 2. And then equals, and the x plus 2 cancels, and we're left with 5 times the x minus 3. Okay, let's write that down. Now let's combine and simplify to see what we have. We have 2x minus 1 on the left-hand side equals 5x minus 15 on that side. Subtract 2x from both sides, we get minus 1 equals 3x minus 15. Add 15 to both sides, we get 3x equals 14. Is that right? Add 15? Yep, 14. Divide by 3, and we get x equals 14 over 3. 14 thirds. Let's double check to make sure we didn't violate any domain problems here. Nope, a negative 2 would be the bad one here, and a positive 3 would be a bad one there. So this is a safe answer. All right, number 6. Common denominator has to have a t plus 2, a t minus 3. Looks like that is our common denominator. So let's times both sides by t plus 2, t minus 3. Got to do it to every location. T minus 2 times t. Oh, that's a plus 2 and a t minus 3. And then t minus 2, t plus 3. Good. Okay, so when it hits this first one, the t, let me fix that. I just did it wrong again. T plus 2, t minus 3. The t plus 2's cancel here. We get 1 times t minus 3. The t minus 3's cancel here, and I'm left with plus a t plus 2. And then on the other side, t plus 2 cancels, t minus 3 cancels. And it's kind of weird. We really just canceled them. We decided that we wanted to multiply by this random number on both sides to cancel out the fractions, and we just get a 5. So we get 2t minus 1 equals 5. Add 1 to both sides, we get 2t equals 6. That means that t equals 3. Let's double check and make sure that 3 works in there. Oh, look at that. If we stick 3 in right here, it turns the bottom to 0. So this guy right here, there is no solution. Because 3, the only number that would work, can't go in there. It'll cause the bottom to go to 0. So no solution on that one.